Hello everyone, I am Muhammad Ahmad, consultant engineer in Cervenka Consulting, and I would like to show you today some tips and tricks in our main preprocessor GiD. Let me start by sharing my screen. We'll start the presentation. So before I go through my presentation, I would like to mention that nowadays we have two main preprocessor, our ATENA preprocessor 2024 and also GiD. In this webinar, I will focus on GiD, which is our main preprocessor. The latest version of GiD is now 17, so please update your version in case you haven't. In this webinar, I will show you how to create your model in simple way, even if you have very complicated model. What is the easy way to create the mesh or to create the contact volumes or the interface? Our first example is about offshore wind turbine. As you can see from the photo on the left, the base of the wind turbine going inside the sea. This is the water level and connected to the ground by the grounded connection, as you can see the photo on the right. So this is our model to simulate or to create the model for the grounded connection, which contains the pin coming from the top, from the base, going inside the pile, and then this space between the pin and the pile should be filled by a grout or very high strength concrete. As you can see, also there's some small nuts like on the surface of the pile and the pin, which is the bits welded to these surfaces to simulate the confinement, which is our purpose in this model. At the first glance, you could say this is very complicated to do it in GiD, which is true. But if we think a little bit before we model it, it will be very easy model to do it. So I will show you how we model this grounded connection in GiD. First of all, we simulate a 2D plane for the surfaces from the pile and the grout and the pin here. So we just took these surfaces and we simulate them here. As you can see in GiD, the blue surface represents the pile and the green the pin, and also the gray represents the grout. And also we simulate the bits, as you can see here, and we divided the surfaces near to each bit to have the compatible mesh later. We always use layers, and this is one of the main keys in GiD. Always use layers to make it easy work for later when we create the volumes for each surface. After I create my surfaces, I need to check the mesh if it's working well, if it's good mesh or not, and whatever, before creating any volumes. So what I did here, I assigned quadrilateral elements or element types for the surfaces to get this kind of mesh. And as you can see, the compatible mesh, like each element from the grout here, sharing the same line with the pile, and also from the pin with the grout as well, because there's just one line between the surfaces from the grout and the pile, or from the grout and the pin. After creating the mesh, then I need, or I can extrude these surfaces to create my volume. I will do that by using a copy command, and I will rotate my surface 180 degrees to create my volume. So from this copy command, as you can see here, we say like I have surfaces, I want to extrude it to volumes, and transformation, I want to have it rotation. So I check here the rotation box, and I put like 180 degree if I need to create one single volume from these surfaces. What I did here, I just create three surfaces, three volumes, sorry. So I put here multiple copies of three, and instead of 180 degree, it will be 60 degree. Why I did that? Just to simplify it for the GiD. Sometimes if you have one single volume, it could lead you to some errors in the measure. So better always to help GiD a little bit when you have some complicated models, and divide your volumes even into small volumes. After creating the volumes, I need to assign the mesh. So I assigned the mesh structured mesh and semi-structured mesh for these volumes, and then create the volumes to be sure that my mesh is okay. And as you can see here on the right, we have the final model without any problems. After that, I need to create the interfaces between the pile and grout, and between the pin and grouts, which is the most important and the more difficult trick here in this model, which I will show you later when I will create this model in GiD. Now let me switch to the GiD model to show you how I can create the volumes and the interface quickly. So as you can see here, we have just 2D model. It's just surfaces. And as you see, as I mentioned, like the divisions, just to have compatible mesh, as you see here, like this surface for the beads, sharing the same line with the surface here for the pile. Again, here the same, the surface from the pin sharing the same line. If just to be sure, like we can make here, we can see there's just one line sharing two surfaces. And in this way, we will have compatible mesh. If I generate the mesh, Control G, and then I can see the mesh will be generated in this way. Now I want to extrude these volume surfaces into volumes, so I can activate the copy menu, and then I can say here I want to have it where I have surface, I want to have it volumes, I want to keep it like collapse activated, so I don't need any overlapping, and transformation, I need to switch from translation to rotation. And in this way, I can have here the degree, and also here how many types. Just I need to have the axis rotation where I should rotate my surface around. And this should be the center of the model. So it should be around this line. So I need to have here like whatever the point, like here, for instance, and the one here. So this is my rotation axis. All the surface will rotate around it. Here I need to have three volumes. Each volume rotates 60 degrees. And here I need to have three to be sure. Then I will just select all the surfaces except this one, and then will be rotated in this way. So I will have the full model, as you can see here. After creating my volumes, I need to assign the mesh to be sure that everything working fine. And then after that, we can start creating the interface. So to assign the mesh, I need to, I always put all the volumes into their layers to be easy working. So this is the grout, and here the pin. So I need to assign a structured mesh for pin and pile and semi-structured mesh for the ground. So structured, I need to have it like this. For instance, firstly, I keep it like 2, so we will see later how it will react. With structured mesh, always element type hexahedra. And then if I deactivate it, grout connection, oh, the grout should be semi-structured. And element type hexahedra as well. After setting the mesh setting, we generate the mesh just to check if we have it or if it's working or not. And then we can check or change the element sizes. As you can see, it's working now, but it's really ugly in this side because we need much more elements. Yes, so we need to have the division like in each like line here. It's at least 6 or 7 to have it nicer, or like to have it fully arcs. At final, we need to have it like this so we can see like it's nicely smooth and nicely like going as arcs due to many elements through this thickness. Yeah. After generating our mesh and like be sure like everything working well and like the mesh is okay. Now we can create the interface between the pile and the grout and the pin and the grout. So we need to create the like extra surfaces to be not sharing. Like now the pile and the grout sharing the same surface, even here like the pin and the grout sharing as well the same surface. So we need to have separate surfaces. I can do that easily by moving the grout volumes. Uh, so I can just activate the move menu, and here I should deactivate collapse, and I should have like volume what I need to move. I don't need to put any numbers here like in directions. I don't need to move it far away and return it. It will lose the mesh setting if I did this way. So I can just move it in the same place so it will save or it will keep the mesh setting as it is, which I need. And now I can create, for instance, here interface. So always we uh, rely on layers here to help us. And I can say here, like I don't want it that the new surfaces, I don't want it in the same layers for the volumes. I need it into interface layer. And if I can select, then all the new surfaces will be just in this layer. So it will be easy for me later to create the interface between these surfaces and the pile or the pin. So like I just isolated the surfaces for the grout to be just in separate layer to be easy to create my interface later. So this is how we model this very complicated model into a very easy way, as you can see, uh, just by following some simple steps and ordering our like surfaces into layers and like trying to make it step by step, not everything into one step, then everyone will be lost. So it's a very complicated model, but very easy how we can or how we could do it. Yes. Let's now move to our second example. Second example is about connecting a steel plate with a concrete slab on the top by a shear connectors between them. As you can see, the photo on the bottom, the shear connectors are the volumes with blue colors. These shear connectors are welded with the steel and embedded inside the concrete in this area, the pink area. You could say this is a small or a simple model, which is not true. Uh, According or due to this area, where the shear connectors inside the concrete, making the model is very complicated because you need to have uh, holes inside the concrete or inside these volumes and connect each side or each surface from the connectors with the concrete by interface or contact volumes. The main trick in this model, it was about the mesh for the bolts or for the shear connectors. As you can see, we have on the left, we have a structured coarse mesh for the bolt, and on the right, we have the semi-structured uh, fine mesh for the bolt. I will show you the results first to show you how much important it was the mesh here. So as you can see, this is our coarse mesh and this is our fine mesh. And even it's totally different behavior when you have coarse mesh. So let's imagine like when we apply the vertical load on the load plate here, we apply the vertical load, so the concrete slab will slide because the interface between the steel and the concrete. According to this slide, it will create a horizontal force applied on the shear connectors. So this concrete will push against the shear connectors in this direction. So we need a really fine mesh in this direction to have as much as we can, uh, as much elements as we can to capture the correct or the bending properly. Even we have also here, we need to have very fine mesh through this thickness because we need to capture or we need to be close to rupturing. Later on, this in some places the bolts will rupture the welded between the bolt and the steel. Here, the comparison between the experiment and the coarse mesh and the fine mesh. And as you can see, even with our fine mesh, we are still a bit higher than the reality, but it's much better than the coarse mesh. Third and final example is about push-out test. It's very similar to the example before, but here it's a push-out test. This test contains two concrete slabs connected to the steel beam by connectors inside, as you can see here. Here you can see the cross section for the model. As you can see here, the concrete and here the steel and connected together by this bolt inside. And between when we will model it, we will have interfaces between steel concrete or bolt steel or bolt concrete. Here you can see a nice comparison between Abacus and the ATENA results. And the main trick here in this model, it was again the mesh and number of elements, especially in the critical area, which is the bolt in this area exactly. So as you can see, we made very fine mesh for the bolt and coarser for the steel here, or even coarser for the concrete and steel around to save the time running. And we need just to have the very fine mesh into this or for this area. Here it was very important to use master slave between the interface and the concrete because we have different mesh size, as you can see, between the bolt, concrete or bolt and steel. So here the function or the command master slave or fixed contact, it was very important. Finally, we can see here the very nice matching between the cracks in ATENA model and the cracks in reality. Now let me move to the GID to show the example there. In this example, I will show two important matter in GID. First, how to create a hole between two elements, and second, how to create a proper interface or contact volume. So what you can see here is a steel beam, and here the bolt, and should be connected in this side by the concrete, as you can see, the same as here. I will not show the concrete for now to make it easy or to simplify it. And also I will add this part to this layer and turn off this layer. So I will keep this flange where it's connected with the bolt. And I will go through these elements. Firstly, here we have a flange steel, and here also we have a bolt in blue layer. Then we have the nut inside and also the nut outside. As we know, like the nut here should be hollow inside to allow the bolt to go inside and screw inside. Also, this flange should have hollow around the bolt to be able to uh, go through it. If we check it here, like I just make it a simple model. So if we check it here, we can see there's no any holes here. So we will see how we create these holes and how we create our model or prepare our model to make it easy for later to make a contact. As we can see here, we have one single volume for this one for the bolt. And what I need to do now, I need to divide this one single volume into 3 volumes instead of 1. Why is that? To have like one volume from the beginning till the first of the knot, then another volume from the first of the knot to the end, and then one small volume here between the flange and the bolt. Why is that? Because I need the interface later between the bolt and the nut, and also between the bolt and the flange here. So I need two surfaces with the same side. Yes, one surface from the bolt and the other from the nut. To do that, I need to delete first the volume. After I delete the volume, I can delete all the surfaces related to this volume. I need also to create the hole later in this nut. So I need also to define the volume here. So I need also to delete this volume for the nut. After that, I need to delete the surfaces for the bolt and also the surfaces, the outer surfaces for the nut here. So I have now just the outer lines, as you can see. Now I need to create the volumes. I activate the copy command. I have surface. I need to extrude to volume, use collapse. Firstly, the distance from here till the first of the knot will be 0.07 on y direction. So 0.07. So I have now first part of the volume for the bolt. It's like till the first of the knot. Then I need to continue. So from the first of the knot till the end of it, I need this surface to extrude into the volume inside. You can see it now like this. Then I have the rest. I will have it from this point to this point like that. So now I have my my bolt divided into 3 volumes. Now I need to create the surface for the nut with the hole. So what I can do is to just assign the outer lines for the nut plus the outer lines for the bolt here, and then I will have this surface here. I put it in this muffler just to see it clearly, so I can see now it is with a hole like this. Now I need to create the volume for this nut, so I need to have also surface to volume from this point to this point with this. So I have now my volume like that, and if I check it, it's like this, as we can see. Now, same way we needed to have or we needed to create the hole between the flange and bolt. So I can see here the hole I created to just save the time. Now, after we create the holes between the elements, we need now to check the mesh. Always when you finish the main step, generate the mesh before any interface created, to be sure like your model is okay, your mesh created well, and so on. I will set the mesh here as semi-structured for all the volumes, just to set it quickly so I can just check if it's working well. Now I can see my mesh is like that. We can for sure generate or like make it much better. Now it's very ugly, especially here. As I mentioned, like the bolt should be very fine mesh. To do that, we can go here, unstructured, assign size for structure, for surface, sorry. And then here we can make it 1 millimeter or 2 millimeter or whatever. I can keep it 1 millimeter. And then I want to set it for this surface and then generate mesh again. And then you can see the mesh much nicer for the surface here as you see it now. After I generate the mesh, I am sure that my mesh is okay. We can modify it. We can modify our mesh before we do anything if you want. For instance, like here, I can even make it for the global mesh like a little bit length, for example, 0.02, to make it much nicer. As you see now, it's changed to be much nicer. Here, maybe we can set more lines or more elements for line to be the same as here, these lines. So we can do, we can set the mesh or prepare the mesh before we continue to the interface, which is much better. Let me, for instance, like set the same number for the lines, so it will be easier for me when I will separate the volumes. When I will create also the interface. So here I will put all the lines, 4 elements. So all the lines here, 4 elements. So it will share the same element or the same mesh element. And this will help me so much later on when I will separate the volumes to make the interface. We can make it instead of 4, 6, or 8 even, to make it like here much finer. So this you decide according to your initial results. Anyway, now the mesh is working, so I need to create the interface between the bolt and the nut, and also I need interface between this nut and the flange. Again, I need to interface between the bolt inside and the flange. So all these interfaces, we should care about them and create them. So let me start with interface between this nut and the bolt. So to do that, I need to move either the bolt or the nut volumes. And as I mentioned before, like we just need to move them. Okay, it's not working by this, so can go here, git generate or activate move. I need to move the volume without collapse, so I deactivate here, and I need to generate an interface, and I can say this is the interface between the bolt and here it's called MUF, so I can say BM, so bolt M, and this is the interface will be between this and this. Now I need to move the volume. I will choose the volume of the MUF or the nut here. I will move it. Now you can see 4 new surfaces are created. And these surfaces, we can check them because I put them into the interface layer. So these surfaces should be related to the MUF one. If I make here like volumes, it will be inside this layer again. Yeah. So I have their own surface, the nuts, and also the bolt. It has their or its own surface here, yes, around also. So always try to use the layers to understand if it's okay, if everything okay or not. So if I have here like all this for bolts, so and then if I activate the mouth, I see all the lines or the nuts inside this layer. And so if I deactivate it and activate the bolt again, we see also all the lines and nodes and surfaces relating or related to this layer. So we have to, if we activate both of them, also we can double check by checking this. So here we can see 2 surfaces, here also 2 surfaces. If I want to check the points, for example, you can see here 2 points, also here 2 points. So we are in correct direction. Now to create the interface, I need firstly to check the direction of the interface from the swap normal. So I need to have like the bolt going against the nut and the nut going against the bolt. So I need to go here, swap normals, surface. So all the arrows here should be outside from the bolt, which is now correct. And if I activate the nut again, swap normal surface, all the arrows here should be going inside against the bolt. So I need to just one click and it will change the direction. Now both of them, you can see like one going inside, one going outside in all the surfaces. And now we are ready to create the interface. We create the interface from create contact volume. I should activate this interface layer to put it inside. Then I drag on 2 surfaces, as you see here, add 2 surfaces should be to draw my interface. So by this way, we can create our interface between the bolt, as you see here, between the bolt and the nut outside. Now, to be sure, like my work is okay. I need to generate the mesh to be sure like everything is okay. And you can see now the interface is like this. Now, one last thing I need to mention about is the interface between between the nut here and between the flange. Yes, because the nut, it has much smaller surface than the flange, so you don't need to divide. You can divide the flange to be the same surface size, but you don't need to do that. Especially here, we need to modify and play with the mesh in each part. So always we recommend you to use a separate surface for interface and connect it to the main surface by master slave. So this is what I will do now. If I want to create an interface between the nut here and the flange, I need to create an extra surface compatible to the surface with the nut here and connect it to this flange by master slave. So what I will do, I will first create a layer, which we always recommend you to create for each step or for each new step, a new layer to help you control your work. So I will call it interface flange M, so FM, let's say. And here I will put my extra surface. So I will copy a surface for zero contact or for zero distance, and I will put it here. So be sure that this option is deactivated, so you can put it directly here. I will select this surface, and then I will check if it's working. So I have it here now, my surface, new surface, main. So this surface, it will represent the flange side, yes? And to represent the flange size, the normal for this surface should be against the normal of the nut surface. So here I should check the normal. So it should be here the nut. So it will be the other way around. So it will be like this. It should be like this. Now, if I check the surface for the nut, should be against to the surface of the flange, so it's okay, it's correct. Now I can create my interface, create contact volume, and I drag here to see two surfaces, and then I have the interface as you can see here. This surface or this interface has two surfaces, one from the nut and one extra surface, and this extra surface I will connect it to the flange by master slave. So I need to activate here firstly ATENA, and now by activating it you will see this new tab and you can choose your conditions. I will go to fixed contact for surface. I will say this is the slave because like this is the small surface. I will connect it with this surface for the flange, as you see here. So I will say this is the slave. I will call it FM, the same name of the interface. I will select this, then I will switch to master to select the flange surface. I will be sure that drawing here master here the red and slave is the green, as you can see. So by this way you can create your interface if you don't have the same sizes of the surfaces. And by this way we can say like we completed a quite complicated model, has many holes, many interfaces, and we showed you how to simplify it and how to deal with that.
ATENA program produced by Chervenka company. You can find us via the website and download the program from it, or on YouTube by name Chervenka Consulting, or in Facebook by name ATENA. Finally, we thank you for your attention, and for any inquiries, please don't hesitate to contact us. Have a nice day. Bye bye.